Hello geometry students, welcome to chapter 6. Line symmetry is the first lesson. Chapter 6 is all about parallel lines. So, what about symmetry? You're familiar with line symmetry. You have an intuitive understanding of it from previous courses. Well, here's the formal definition of line symmetry. Two points are symmetric with respect to a line if and only if the line is the perpendicular bisector of the line segment connecting the 2 points. Alright. Now, that may not make a lot of sense to you as you hear it, but we have a picture here in a minute that will help clarify it. Theorem 16 is the big theorem in this one. This is one that doesn't exactly roll off the tongue. This is one that people have a hard time remembering from year to year. So you might want to put a little extra time in making sure you've got this one. In a plane, 2 points, each equidistant from the endpoints of a line segment, determine the perpendicular bisector of the line segment. Alright, so what do we mean by that? Let's have a picture here that'll help us clarify. Alright, so what are we talking about in this? Here you've got points, 2 points, each equidistant from the endpoints of a line segment, determine the perpendicular bisector of the line segment. So I suppose we really should have another point up here, which we can call D. Alright, so the 2 points, each equidistant from the endpoints of a line segment, that would be points C and D, determine the perpendicular bisector of the line segment. They are equidistant from A and B. Alright, so C to B, the distance from C to B is the same as the distance from C to A. The distance from D to A is the same as the distance from D to B. And these are the perpendicular, this creates the perpendicular bisector of the line segment. Alright, so let's think about this again. In a plane, 2 points, each equidistant from the endpoints of a line segment. So we're talking about 2 points each equidistant from A and B. That would be C and D. Those 2 points, C and D, determine the perpendicular bisector of the line segment. So if we draw a line through those 2 points, we'll have its perpendicular bisector. You see how it's marked? From A to the midpoint here is the same length as from midpoint out to B. And there you have C and D. So even though this chapter is about parallel lines, we're starting out by talking about perpendicular lines, aren't we? And that's what we're going to be doing here in this lesson, dealing with perpendicular lines and line symmetry, because as you can tell from what you know about line symmetry, perpendicular lines are very important to it, because this could be, you could think of this as a line of symmetry. If I folded this line segment AB over this line here, A would fit exactly on B, wouldn't it? Right, so that's how it's symmetrical. Okay, and we have a couple of constructions, both dealing with perpendicular lines. So let's have a look at some constructions here. See how long this thing takes to load up today. Oh, it's pretty fast. So now we are going to do these two right here. So perpendicular to a line from a point on the line. Let's look at that one first. This is on page 213 in your book. You want to follow along there, or if you just want to watch the computer do it, you may do that also. Okay. Well, now it's slowing down. But it'll be here soon enough. Once it gets loaded in, then we'll get the full screen up here, and we'll go from there. Alright, behold, a line, this blue line here, with point K on the line, So we are constructing a line perpendicular to the given line at the point K on that line. The compass set on K, set it to a medium width. That just means a comfortable width. So here's our compass. And then draw an arc on each side of K using that compass width, creating points P and Q. So you don't change the compass setting. So now what you've done is you've created 2 points that are equidistant away from K on each side. Alright, with the compass set on P, set its width to about halfway between K and Q. So you want to go past this midpoint K here. And now draw an arc on one side of the line. Without changing the width, we repeat from point Q, creating point R as such. Alright, now what you have done is created a point that you can use to draw a line segment through K. This is a perpendicular bisector. The distance from P to K, you know from your compass, is the same as the distance from K to Q, and we have 90-degree angle here. Alright, so that is how you do it. Let's try it one more time. Just have a look at it. So, steps are this. We've got the compass, sharp point on K, using the same setting on the compass, arcs on each side of K, and 2 new points created. From those 2 points, we're going to make arcs above K. And that gives us our reference point to make our perpendicular bisector for this. Okay. So now we're that was constructing a line perpendicular to another line through a point on the line. Alright, let's go back and get the other one now, which is perpendicular to a line from an external point, a point that's not on the line. So the only difference you're going to see here really is the point we start with is not on the line. So now you see here's our blue line like we had, but this time the point is not on the line. But we do it basically the same way. We put the sharp point on the point that's not on the line, and then we extend the compass past the line and draw arcs on each side of the line that intersect the line in 2 different places, that is, P and Q. And then from those 2 points, now we make arcs on the other side of the line, below it here. Right, and again, what we've done is establish a reference point that we can use to draw the perpendicular bisector of this one. Alright, so this is the new line. It's perpendicular to PQ and passes through R. Alright, so that's the difference. Let's watch it one more time, then you'll have it. So always we start with a sharp point on the point, wherever it is, whether it's on the line or off the line. We always put the sharp point on there, and we want to make arcs that intersect the line, whether the point we started from is on the line or off the line. Now here's a little different on the point that's off the line. Now we make arcs that intersect below, so that was with the sharp point on P, and then an arc made there, and the sharp point on Q, an arc made here, and then you have what you need to make the line. Alright, that's your constructing a line perpendicular to another line through a point that is not on the line. And you can see it run on its own now because it is got this down pat. And you will too. Okay, there you have that. Let's get out of this. And now back to our line symmetry, and that's the main parts of lesson 6-1 on line symmetry. Theorem 16, in a plane in 2 points, each equidistant from the endpoints of the line segment, determine the perpendicular bisector of the line segment. That's the main thing you've got to know about this. Have a geometric day.